Welcome everyone. Thank you for coming. So at exactly 5, I think we'll start, but we'll begin with brief introductions. I think we'll get an introduction from the teams, the trainers. Then after that, we'll also have now the participants. You're quite many, so we'll just introduce yourselves in the chat using the chat function. Just introduce yourselves in the chat, and then so that we can continue with the presentation and the bootcamp. Hope you can hear me.
Yes, Kisa.
So thank you again for registration. We are the organizers of this training bootcamp, and just going to take you through who we are as an organization, and then also the lead trainers during this program. So we are an online mapping community that was formed last year, 2020, in the first lockdown, and the role of the community at that time was to provide geospatial data that is needed by both government and non-government agencies that are working in urban communities and also working in emergency responses. The community was started with 5 volunteers, but now we have grown to actually have more than 40 volunteers. So we use different platforms to get this data, the spatial data that we use, and we contribute and then clean it and then send it to data users. The first instance that we use is online mapping, where we use satellite imagery. For example, this is one of the volunteers who participated in a project last year using satellite imagery from Esri, from Maxa Planet. We get that imagery, then we trace buildings and roads, and then after that, we complement it with images that are obtained on ground, for example, mapillary. And then we use editors such as ID Editor and JOSIN. And then the data that is collected is then uploaded to OpenStreetMap. And then we also carried out trainings. The first instance is in ID Editor, OSM ID Editor, and Java OpenStreetMap Editor. Now, these are editors that are used for creating data on OpenStreetMap. If you know GIS, if you're familiar with GIS, then you've possibly heard of OpenStreetMap, where data is created daily there. And actually, you can also access it and download it. You can also create data and upload it there, the spatial data, and use it in your projects also as well. So simple trainings on ID Editor and JOSIN, and also an open tool, which is called Open Data Kit, which is used to collect data, which is also open source. You can download it and configure it onto your smartphone, and then you use it to collect GPS data or GIS data. Then also we carry out trainings in QGIS and ArcGIS desktop. For example, this training, this bootcamp that we're going to have about QGIS. And also the same content can also be created for actually ArcGIS desktop, which we're planning to have in the next coming months. And then also, we also have competence in ArcGIS online services, that is web maps, dashboards, and Survey 123. We can also carry out trainings in these tools in case you need it in your organizations. We also carry out, since we have a team of volunteers that we work with, we also have volunteers who can actually go out in the field and collect data for that is needed. Now here, the platform that we use ODK, Survey 123, and also Mapillary using a smartphone, since it's way cheaper than a normal GPS, a normal handheld GPS. So we'd use a smartphone to configure these apps, and then we use it for collecting GIS data. We also carry out trainings on how to use these mobile applications. Then usually the data that we collect from the field and also from online mapping, we actually use it to create these kinds of visualizations, which sometimes can be in terms of printed maps that you will also learn during these sessions, upcoming days. And also you can also create web maps. As you can see from here, this is ArcGIS online. This is a web map where we're showing services that are in the informal settlements in Kawempe division in Kampala, health services, financial services, water and electricity distribution. The link is here in case you want to visualize to see how actually it looks like. This is showing the building footprint, the conditions of the building footprint in one of the informal settlements there. And then we also have a dashboard which is showing the services that are available also in these communities. For example, the number of health centers, even the waste dump sites that are in these areas, those ones that are illegal and legal. For example, you can see from this video that I touched, it's a snippet from the dashboard that we created. So from the data that we collect, we actually use it to create all these kind of products. That we are with those people that are in need of them. So for this 5 days of the program, we basically have 5 modules. On the first day, we have introduction to GIS and QGIS overview. So in this case, we are going to look at the theory of GIS, what GIS is, the basics of GIS, because I understand we have people from various backgrounds, so some may not be knowing what GIS is. And then we also have people who have a little bit of experience with what GIS is. So we're going to go through an introduction of GIS. Then after that, we're going to see how the software that we're going to use in the next 4 days, how it looks like, where to find the recommended tools that you can actually use, how to import in data, how to load in plugins, things like that. Then on the second day, because I think most of us are familiar that GIS is basically the final output is a map, whether it is a web map or it is a printed map. So usually we're going to take you through how you can produce a beautiful map using the QGIS software. So of course, things like picking the right color in case you're producing a given feature. Maybe if your map is about terrain, maybe your map is about population, what kind of colors should you choose to use? Or which scales can you use when you're producing that map? Then the next 3 days, day 3, day 4, and day 5, we shall be having case scenarios where we have real problems in the world, and then we try to use our knowledge of GIS to come up with a solution. So for day 3 and day 4, it's going to be response to COVID-19. The first case will be modeling access. So of course, there are some areas that don't have access to some of these facilities, these basic facilities. So we're going to use GIS and try to find a way to determine which areas actually have and which areas do not have. Something which you can't just tell with your naked eye, or something which you can't tell with just Excel data. Then on day 4, we shall be having, because you know you've been hearing cases of COVID-19, maybe in Uganda, Kenya, Tanzania, past cases ever since COVID-19 broke out. So you have all that data in the history, and you want to come up with the visualization showing how the cases have been increasing over the years or over the months ever since COVID-19 came. Then on the last day, we shall have a session where we have the case scenario where we have like an investor wants to actually come into the country and set up a park, and then now using his criteria that you would want to be considered when they're coming up with that park, he now requires you to actually use your GIS knowledge to come up with the best locations that that person can develop that park. You get it? So these are the 5 days, the content that we shall be having during these 5 days. And once again, thank you for registering, and thank you for coming for this session. So I'm just going to have a brief introduction of the trainers, who they are, starting with Rehema Nachibuka. She's a geospatial enthusiast, also holds a bachelor's degree in land surveying and geomatics. She's one of the lead trainers and also founders at Resilience Mappers. She's also a training associate with OpenStreetMap Uganda, and also a spatial data analyst with GVA Uganda. So she's more of like a geoinformatics engineer. Then we have Jesse, also, who's going to be a facilitator. He also has a bachelor's degree in land surveying and geomatics. And he's been using actually GIS and remote sensing in most of his life. He has worked on several GIS projects. The first one being that he modeled water quality on Lake Victoria, and also carried out a spatial and temporal land cover mapping of the Jinja Kampala Entebbe corridor. You know that corridor where they are going to construct a new highway. He also carried out using GIS and remote sensing, and carried out that kind of analysis. He has actually a very active YouTube channel. I think you can just search on YouTube, Jesse Buyungo, and he has very many tutorials on GIS. By actually just following him, you'll be able to learn a lot about GIS. Then me personally, I'm also one of the trainers. That's me. I also hold a bachelor's degree in land surveying and geomatics. Currently, I'm working as a GIS analyst at GGI Uganda, where we're using Esri resources and technologies and satellite imagery in conservation of chimpanzees in Western Uganda. I'm also the lead at team lead at Resilience Mappers, providing the kind of leadership that is needed to the online community. All right, that's just the basic introduction. I still encourage you to keep on introducing yourselves in the chat as we get to know each other. Okay, just if there are any questions, I think we can have like 2 minutes, 2 questions, and then we can have an introduction to what GIS is. In case anyone has any questions, I think you can post it either in the chat, or you can unmute yourself and then ask any question.
Yes, Chisa, I think we can continue. I can't see any question here. I think you can continue.
All right, thank you, Jesse. Just at the beginning of this brief introduction, I have a video that I want to play. Hope you can hear it. Yes.
What is GIS? GIS stands for Geographical Information System. Simply put, GIS is a business information management system that helps us capture, analyze, and present spatial information on a map. GIS allows us to make better decisions using geography. What can GIS do for you? Every day, millions of decisions are powered by GIS. Retailers use GIS to pinpoint the best locations for new stores and stock items that match local customers' needs. GIS is used by the conservation organisations to predict the likely consequences of global warming. Utilities organisations use GIS to respond promptly and efficiently to reported power outages. Police forces use GIS to discover patterns in criminal activity and plan operations much more strategically. Resulting patterns and trends can then be seen on a digital map, much easier than viewing the data on spreadsheets. How does a GIS work? GIS software runs on computers, ranging from the most powerful server to software on your mobile phone. In a GIS, information about the real world is stored as a collection of thematic layers linked by geography. Each layer contains similar features, such as streets or rivers. People can then analyze geographic data using GIS tools and visualize geographic data as maps, graphs, or charts. Patterns and trends can easily be identified, so information that was previously buried in a spreadsheet now comes to life. Let me give you some examples. Retailers like Nike and Levi Strauss use GIS to avoid making costly mistakes when opening new retail locations. The Department of the Environment uses GIS to manage conservation in our national parks, maintain the biodiversity of our landscape, and preserve our national monuments and sites of architectural heritage. GIS helps the Department of Education to make sure they provide the right number of school places for children in the right locations. The police service in Northern Ireland harness GIS to make smarter use of intelligence, which helps reduce crime and costs. In short, GIS allows us to make better decisions using geography. Complex analysis is made simple, and decisions become clear. At Esri Ireland, our business is built on the belief that knowing where things happen matters to your business. Maps make sense, and using them, we can help you make sense of your geographic information. To find out how maps can make sense for you or your organisation, contact us at mapsmakesense@esri-ireland.ie.
Yes, so that video basically is talking about what GIS is, where it is applied, and in simple terms, what actually it is. And that's basically what we're going to be talking about. Forgive that it's a promo video.
What is GIS?
So GIS, GIS is a computerized system that actually facilitates three phases. The three phases that are facilitated, we have data entry, analysis, and representation. In cases when we're dealing with actually data that is georeferenced. So in GIS, which in full is a geographic information system. So with it, the three phases of data entry, analysis, and representation are actually facilitated. Now, GIS, besides those three phases, for example, now data entry. Data entry is before you actually work with GIS, you would need to collect data in the field. The data that can be actually collected can be either you go out in the field and collect it, or you can actually sit on your computer, as I shared before, and actually digitize some of from the raster data, digitize and you come up with information that actually you can use in your system. So it's more of a system that facilitates those three phases, and especially when you're working with only data that is georeferenced. Now, when we talk about data that is georeferenced, this is data which is associated with a position on ground or in the real world, which is, yeah, which has a position, he has coordinates on ground. So data is not just any kind of data, for example, data which is in your Excel table. So GIS basically works with data that at least should be having coordinates. Any kind of data that doesn't have coordinates, then that can't be considered to be worked with in GIS. So after getting your data from the field or from any other source that you get, then now you reorganize it, organize it very well. Then after that, you carry out some analysis on your data, and then come out with the final output, which is the visualization, which can be either in form of a web map or a printed map. These are the three stages, the important stages, as we shall be seeing in the subsequent days. Actually, these three phases, whenever you open the software itself, you will find out that you have to get data. In case for every kind of analysis, for every kind of problem that you're trying to solve, you will have to first obtain data of that phenomenon that you're trying to investigate. Then now the first step would be that you prepare that data very well, organize it, clean it, as you'll find out that that process, the first stage, is actually usually the most important stage of GIS, because if you don't clean your data very well, that means you'll be having wrong data, then you'll carry out analysis on that kind of wrong data, then that means even your results will be wrong. The representation that you'll be presenting to your clients won't be the correct data or the correct information. So just like garbage in, garbage out, you have to take time to prepare your data, to clean it, and come out with the correct data, very well data. Then after now that, you can enter it into your GIS system, which can be the software. Now the software can be linked to a database, so you can maybe put it into a database and then link it to your map. Then you can always import it. Then after preparing it and entering it to your GIS system, then you can now carry out an analysis on that data. So the stage of data analysis is where the data is actually reviewed now, and attempts are made to try to discover patterns within this data. So now in this stage, that's when now different tools are actually used, different tools in the software or in GIS are used to actually carry out some analysis. For example, maybe your raw data could be, maybe you went to it in the field and collected the elevation data from the field, maybe coordinates of, and also coordinates X, Y, and also their heights on ground. So now this data, then you import it, now elevation data, you import it into your GIS. Then now the first step would be, of course, now to carry out some SIP analysis. Maybe you generate a DM from it. Then after generating a DM from it, then you also carry out a slope, just to understand what is, what kind of pattern is in my data, something like that. And also carry out more. Now the analysis can start from the basics analysis, then there are also very more complex analysis. So you carry out different analysis on your data, combinations of analysis. Then you, after that, you now go to the next stage, the final stage, which is data representation. So after carrying out the analysis in the data, then you apply different colors, different colors, different fonts to your product. Then now you come up with the map that usually is the final output that you give it to the client. So now these three phases, it's not like when you finish data preparation, you don't go back to it. So they reiterate, like maybe you do data preparation, you get your data, you collect it in the field, then you import it into the software, then you try to do an analysis, then you find actually that the data that you collected from the field isn't enough for you to give you the final output that you actually wanted just from the analysis. So now you realize that you need to go back in the field and collect actually the data. So now you go back and collect more data, then you come back again, then you do analysis. Then now after doing the analysis, you come up with the presentation, but maybe from your map, you also still realize that the final output, which is coming out from the map, isn't okay. Then you still go back and do maybe more analysis to come up. So these three phases, it's not like when you finish one, you never go back to it. So it should just be like you can import the first case of your data, try to visualize, doesn't work, then you import it more like that. It's reiterative. So as we've seen from the introduction video, GIS actually is applied in very many fields. Almost all professions currently actually use GIS. Even for example, right now where we're having the pandemic and health officials, so even the health sector, they need to be knowing what GIS is, because now to analyze patterns like where cases are most, where cases are least, such cases, such that we need to know where to put resources, such cases. So almost all professions currently now have to be using at least some component of GIS, as long as that profession has a component of studying anything in the environment, as long as it has something related to the environment. A simple case can be an urban planner. I know very well the many urban planners in this session. So an urban planner can actually, for example, Kampala, can analyze, would want to know how Kampala is actually growing. Is it expanding? And if it's expanding, which direction is it expanding? And how is it changing over the years? What's the quantity of the expansion? How many buildings maybe have increased over the years? And how much of vegetation has been lost, or how much of built up has increased? So actually this kind of analysis is possible within a GIS. And now that's like one case where an urban planner can actually use it. Apart from that, can also be using it to determine now, just by sitting maybe on the computer and doing a simple field work, can actually also determine how much population has grown over the years in the urban areas. Apart from an urban planner, we also have geological engineers. For example, in those areas that are frequently affected by earthquakes, those countries that are frequently, and so geological engineers can actually use their knowledge of the earthquakes and different other parameters actually to find the safest places where they can actually construct buildings that are free from earthquakes, that are, or if they're not free from earthquakes, that have the least impact of earthquakes. So now GIS would inform, that's why most of maybe the buildings that they construct, maybe they're not affected much, because they know exactly where they need to construct the buildings that are at a low risk in case of earthquakes. Then besides that, we have people like forest managers, people who are working, for example, now someone would want to, we know very many people invest in currently in planting trees, especially for timber, and also for timber, for poles. So you would want to know the best place for you to plant the trees and come out with the optimum profits. You get it? So now, of course, you can still use GIS, applying different parameters, different criteria, looking at the different soil types, looking at the weather, rainfall, temperature patterns, and determine the best areas that, in case you want to set up a forest, a private forest for tree production, for timber production, where is the best place to buy the land and then also set up that structure. So now you don't just go out and buy the land. So using GIS, you can actually determine this. Then also, besides that, you can also monitor things like deforestation, areas where afforestation has occurred, using GIS over the years. For example, now people who are maybe in conservation of the environment would want to know if the game parks are maybe game parks and also maybe forest reserves, if people are encroaching on it. So now these are things that are very difficult to see when you just go on ground, but with GIS, you can actually see it and then see whether people are cutting down the trees and encroaching on some of these forest reserves. Then a geoinformatics engineer can actually use GIS to also determine areas where, you know, a company, maybe MTN or Airtel, can set up their relay stations, considering different other factors, for example, the terrain, the best places to set up some of the relay stations, and also set up their networks. Then besides that, also a hydrological engineer can also use GIS to study things like water quality parameters of different areas. For example, as I'd mentioned, one of the lead trainers of this bootcamp, he has carried out studies on water quality parameters on Lake Victoria. So he used, of course, GIS to understand the quality of the water of that lake and how it is changing over time. Maybe considering that maybe from 2010 up to now, is it improving, the water quality, is it improving, or it's actually reducing? So you can actually also use GIS to do that. So GIS is wide, as you all know. We can't finish everything, but we can actually just get a starting point. You can use this bootcamp as a starting point to explore and also choose GIS as a career path. So next, I'm going to talk about the data types that are in GIS. Now in GIS, as you're going to see, there are basically two types of data that we use. We use raster data and vector data. Now, of course, if you're new, you may not know what these two, what we mean by raster data and what we mean by vector data. So I'm going to play a video, and then after that, I'll explain after it.
When using a computer, geographic data comes in one of two formats, either raster or vector data. The best way to describe raster data is to think of it as a picture or digital photograph that is made up of pixels. When you open a digital photo on a screen, it looks okay. However, as you zoom in, the pixels get bigger and the image more blurred and less usable. This is the same with raster map data. With vector data, the best way to think of it is like an architect's drawing or house plan that has been created in a drawing software package. It is made up of points, lines, polygons and text, which can be moved or edited. When you open a vector drawing, it looks good on the screen, and when you zoom in, it still looks okay. The lines do not get thicker or blurred, the data is still usable no matter how far you zoom in. This is the same with vector map data. A good way to show this is to compare a raster and vector datasets side by side and zoom in on them to see how they look. As you can see, the raster data on the right starts out looking more pleasing to the eye, but quickly becomes unusable as it pixelates. The vector data on the left looks okay all the way through. You can just see less and less of it. The most important thing about these two data formats are what you can do with them. Raster data could be considered to be unintelligent. There is very little you can change about it unless you have a photo editing package. If you do, you are limited to doing things like making the image grayscale, adding a tint, or making it negative. You can't remove features from the map or edit them. Basically, it is a very good backdrop or context map. Vector data can be seen as more intelligent. The points, lines, polygons and text all have attributes that mean you can select all of the buildings and make them blue, or all of the roads and make them patterned, or whatever you think is best for what you want to show. It also means that you can switch features off if the map is looking cluttered, so if you do not want any text, it can be switched off. These attributes also mean that you can link your information to the map. So if you have information like opening times, phone numbers and so on about a village hall or an attraction, you can add it to the vector feature on the map, making the map more informative. To find out more, please visit our website.
Sorry about that. So from the video, that basically, and as also mentioned, that there are basically two types of data that we use in GIS. So it's either vector data or raster data. And raster data, you can think of it as an image. It can be a digital photograph. For example, you've taken photos of yourselves. So that's one example of raster data. Now, for the difference with raster data, the digital photograph and what we use in GIS is that the one that we use in GIS is actually has location that is attached to it. It is georeference. That means that actually a point that a building that you can identify, for example, here on this map here, a building that you can identify here can actually, where you identify it is where it is, the coordinates that you obtain from there, that's where it is on ground. So raster data is made up of grids, a matrix of grids are divided into rows and grids, rows and columns. When you zoom in any photograph, you actually find that as you keep on zooming, it becomes blurred, and then you find out that actually has boxes. Now, all raster data has actually those boxes, and those boxes, which we call them pixels or cells, actually have values. Now, for a normal photograph, those boxes or those pixels or cells, they have colors in them, different shades of colors. Then, however, for now, in GIS, those boxes may not have only color, but can also have information in them. Now, the different kinds of information can be like elevation. Like, for example, you see this image here. Now, this is a DEM, but now inside it did. So when you zoom it in, you will find out that actually now those pixels, all the cells, they have elevation values. Of course, you can't see them, but the computer can interpret them. And then also, it can also be having maybe temperature values, or it can be having rainfall values. So now that's the kind of thing, like we have raster data, but instead of having just colors, it also has information in them. So examples of rasters, we have aerial photographs from aeroplanes. You can also have satellite images. Then you also have digital pictures that are taken by camera, or even sometimes you can actually scanned maps. You can have a normal map, that a printed map that you had, and you scan it. Now, when you import it into a GIS, it will be actually imported as a raster. These data types, we are going to see them in the demonstrations. Then for vector data, unlike raster data, for vector data, for raster, the quality keeps on diminishing, and you start seeing those cells. But for vector data, however much you zoom in, it will always be sharp, and you will only fail maybe to see the whole vector data, but as you keep on zooming in, the quality will still be sharp. So vector data is divided into three. We have points, and then lines and polygons. Now, points is just a single coordinate. So now every feature, for example, if you have a vector data, for example, maybe I give an example of schools, have a vector data of schools, and they are represented as points, as vector data as points. Now that means each point will be representing a single coordinate pair, which represents the location of that feature. If I have vector data of maybe rivers, for example, the map that I have over here. Now these are rivers, and they're represented as lines. So here you have multiple coordinates, first of all. So it's like you have multiple points, but then those multiple points are joined together by lines. So those lines that join those multiple points are called line segments. You get so for vector data, you have multiple coordinates or multiple points that are joined together in a line to form in a certain order to form a line feature. However, now the third is the polygons. Now polygons is when now those lines that you've drawn When you have many points, then you draw lines between them. When it comes back to the first point that you started with, so that it forms like an area, then that's now it forms the polygon. The demonstration is quite here. This is a point, just a single coordinate value, which represents a feature. For example, if I've named it as a school, this is just a school, and maybe the name of the school is Katwe Matters, so it's just one school, and it has its coordinates representing it. Then lines, now you have features, because different features are represented differently. So you can find now the best way to, of course, the best way to represent a school can't be in form of a line. So there are certain features, for example, rivers, roads, that are best represented by using lines. So that's how now you represent that kind of feature using that. Then you have features like buildings. Buildings are not best represented. Some of them, depending on the scale of your map, you can represent it as a point, or sometimes if the map is, if it is a large scale map, then that would imply that you have to represent it as a polygon. For example, I had demonstrated in just here. You can see that now here you can still represent it as a point, but the best way would be to represent these buildings as polygons. That's what I mean. Yeah. Then another important component that you need to understand in GIS is the concept of coordinate systems and map projections. It's very important that you understand it, because if you don't understand it, that means that most of the analysis that you'll be doing may not be correct, and you may not be knowing that it's actually not correct. So every map user, anyone who uses a map, even if you don't make it, and also anyone who makes a map, as you've agreed to attend this course, so that implies that you would expect to use at least at one point to come up with a map. You should at least have a basic understanding of map projections and coordinate systems. However much that these concepts have now been automated using computers, the GIS system has automated it. So most people seem to not understand it, or maybe seem to forget it. But it's very important you understand it. Now, these are cases where you need to be careful when in concepts of coordinate system. For example, when you're creating spatial data, the first case would be when you're collecting GPS data in the field, maybe using your smartphone or using any surveying equipment. You need to know the coordinate system that you're operating in, because if you maybe set up a wrong coordinate system, then you go in the field and collect the data. Then now you come up in your software and you're trying to import it, but you import it with the wrong coordinate system into another coordinate system without you knowing. Actually, you'd be having an issue at the end. Even when you're digitizing, for example, because I've had mentioned previously that you can actually create the phases of data entry, phases of GIS, the first stage of data preparation and entry, that you can either go out in the field and collect the data, or you can actually digitize it yourself. So when you're digitizing it, also it's very important that you understand the concept of coordinate systems, because when you're digitizing, for example, usually people, when they're digitizing, you have a raster data, and that raster data is in one coordinate system, and then the new vector layer that maybe you're digitizing into is also in a different coordinate system. That implies now the digitization, the data that you're creating from the digitization, actually it's going into a wrong area without actually you realizing it. But if you're very confident of your coordinate systems and projections, then everything will be good. Even that part of when you're importing data into GIS and overlaying it with other layers that you already have in GIS, it's very important that actually you know that concept. Then also somewhere when you're acquiring data from different areas, for example, maybe you're getting data from Uganda Bureau of Statistics, maybe you're getting data from NFA, you're getting data from NEMA. different organizations, or even you're collecting the data yourself, and all of it, you can bring it into the GIS and you're trying to carry out analysis. So you have to be very careful of the coordinate systems. You need to understand what coordinate systems you're working in when you're importing this data and working with it in the same platform. Then even when you're displaying your data using maps at the end, when you're presenting your map, it's usually very important your final output, the maps that you produce, to also display the coordinate system, so that someone knows that the coordinates that are indicated, that are shown on the map, they're actually from this coordinate system, because there are very many several coordinate systems. So if you just create your map and you put the coordinate and you just create and you just put the coordinates down without specifying the coordinate system, that implies that someone might get those coordinates, and actually when he's going to use them and text him to somewhere else, that is not actually what the map is representing. So it's very important that you understand the concept of coordinate systems and map projections. So I'll take you through a brief of what it is. Coordinate systems. A coordinate system is a reference system for geographic location. If you remember ordinary level mathematics, coordinate systems, basically, if you remember coordinate systems, you have X and Y, then sometimes Z. But even here in GIS, now we have that kind of system where we have the origin and we have something which we could call the Y-axis and the X-axis. But now the only difference is now that it is georeferenced, like it's like on ground, real thing on ground. So if you have an origin, if our coordinate system has an origin, that origin has a specific point on ground. Now, there are two types of coordinate systems. The first one is geographic, and then the second one is projected. If you can see on this globe here, now our coordinate system that is here, the geographic coordinate system, first of all, what it is, it takes the Earth as a globe. So the coordinate systems are basically the globes. So if you've heard of latitude and longitude, that's the geographic coordinate system. Now its origin is the intersection of the equator, which is the 0, because the equator is 0 degrees, 0 degrees latitude. And then also the Greenwich meridian, which is 0 degrees longitude. So that intersection of the Greenwich meridian and the equator forms the origin of the geographic coordinate system, which is 0, 0 here. Now, then all other points on Earth will be having coordinates based on that coordinate system. For example, maybe in Uganda, any point in Uganda could be maybe 33 degrees of longitude. And then upwards, you can see upwards. Now that's when now also the values of latitude increases. So we could consider latitude as the y-axis, then the longitude as the x-axis, because you can see it's x. The upper part of the equator is positive, and the lower part of the equator usually it's a negative. If you specify that it's degrees south, then you don't need to put the negative. Then a projected system is because we know that the Earth could be considered to be round or a sphere. But usually the final outputs that we produce, they are actually printed maps, or they are in 2D. For example, the map that you produce, even if you produce a map on a web map on a computer and put it on a web page, embed it on a web page, or you print it and put it on your wall, that map is actually, it's 2D. It's not like the way 3D, the way it is in the first case. So usually you project that sphere of the real world and project it into a flat surface, as you can see here. So there are very many parameters or ways of transforming the sphere onto a planar surface. One of the examples of geographic coordinate system is what is common as WGS84. I think we've had that one. Then also for projected is the UTM, Universal Transverse Marketer. So the Universal Transverse Marketer, because that's one, it's actually something like a system that we use in Uganda and worldwide most probably, and also neighboring countries in East Africa. So the UTM system was developed by the US military services, and it uses the transverse marketer projection. Now you might wonder, what is the transverse marketer projection? As it's explained here, demonstrated here on this diagram, as I mentioned that the Earth is a globe, so usually you have to find a way of projecting it onto a flat surface. So there are very many ways of projecting it on a flat surface, which I may not talk about it right now. It's altogether a different course. So one of them is what we use a cylinder to do that kind of transformation. So we assume the cylinder encloses that it encloses the globe, and then after that it's projected, the globe is projected onto, yeah, the globe is projected onto the cylinder, then the cylinder is cut, then it's laid onto a flat surface. So usually the marketer projection is this one. This is the marketer projection when the cylinder is upright. Then the transverse marketer is when the cylinder is horizontal. Then oblique marketer is when it's at an angle. So usually when now, because this one, the UTM is universal transverse marketer, this transverse marketer, the cylinder is cut and laid on ground, then comes up with, this is the kind of result, the kind of map now comes out. So now for this UTM system, the whole world is divided into zones, into 36, into 60 zones actually, covering the Earth from east to west. So this is of course the first part, 1, 2, 3, up to 60. And then each zone is 6 degrees wide. For example, so from here to here, it is 6 degrees, such that in total it's 360 degrees to make a circle. And so for Uganda, basically we lie in this region, which is 36. You can see here, if you can see the screen very well, we lie in this zone of 36. That's why usually in most of the projection systems that you'll see, it's UTM. You hear that it is WGS84 UTM zone 36 north. Now, when you hear something like that, it's north, it's because now Uganda, as you can see, Uganda is crossed by the equator. So some part of it is in the upper hemisphere, then another part is on the lower hemisphere. So the different coordinate systems. So the lower parts also now could be considered another one. The upper part could also be considered another one. So the latitude, the reference latitude is the equator, and the origin is 500,000 and 0, 500,000. So now they give it a false value such that the coordinates are usually not negative. Hope that makes sense. So another concept that I think would need to explore is the concept of datums, which could also be considered like a reference frame. For example, now when you hear a coordinate system like WGS84, and then you also hear a coordinate system like WGS84 UTM zone 36 north, then you hear Act 1960 UTM zone 36 north, like that. So those are the different datums that are used in GIS. Thank you very much. That brings me to the close of a brief introduction to GIS. I would invite some questions because I know I was a little bit fast. But I would invite questions.
Yes, Solomon, before we start questions, how many minutes do we have for questions and how many questions are you taking? Thank you.
We have 5 minutes. We have 5 minutes.
Yes, Mr. Solomon. Like in the introduction, you talked about GIS being used in the earthquake monitoring, but I would like you to help me and throw more light about how you use GIS in earthquake, because I don't see any way of using it for internalizing the interior surface of the earth. So if there is any way you help me throw some little light about it, thank you.
All right, thank you. When I was talking about the application of GIS, saying that GIS is actually used in almost all professions, then I talked about a geological engineer. Now, in cases in those areas where actually affected mostly by earthquakes, for example, as I mentioned, Japan, those eastern countries, they would, for example, need to know where the best place. Just an example, they would want to know where the safest area they could actually construct a building, that where they could pass a road. If they're going to construct a road, where is the safest place that they actually should consider when they're going to construct a road? Now here they would have to look at different parameters that now, of course, if it is the safest place, then that means what would make it safe. That means there are different actual criteria that would have to come up with, identify those factors that would actually make it safe. For example, maybe considering historical data of cases where actually earthquakes have been passing in those, maybe have been occurring in some of those areas. Of course, the first instance would be that areas that have never had any earthquake would actually be the best areas to set up a building or to pass a road. Yes, you get it just by looking at that. But it's the application is broad. But as long as anyone is working with location data, as long as whatever you're trying to analyze, any phenomenon that you're trying to analyze is on ground, is in the real world, then you're going to use GIS in one way or another. Hope I've answered your question, sir. Yes, any other questions? Yes.
We have a question in the chat.
Okay. So let me check. How do you know about water quality? As it was mentioned also in the introductory video. Yes, so I think Jesse would be the best person to answer it. Jesse?
Kisa,
Yes, please.
as Jessica comes in to answer this question, you have a couple of hands raised up, like Danish Geoffrey has raised up his hand. Danish, you can go maybe. You can ask a question.
So should I answer the question now?
Oh, yes.
Okay, thank you. I'm just going to use a brief case scenario to answer this question. So assuming today we are interested in modeling the water quality of Lake Victoria, we can't access the whole lake because it is big. So what we do, we get our boat and then we go on sampling a few points on the lake. We collect raw samples like in a flask or whatever equipment we have. And then we make sure that at each point we collect the latitude and longitude location of that place. And then at the end of the day, we shall have many samples which are spatially related to what? To the Earth's surface. And then the next thing is to go to the laboratory and then analyze the concentration of if it is chlorophyll A or if it is chlorine, whatever you are interested in. And then after doing that, you will have spatial records of the water quality points at each location. And then you can either use a remote sensing approach to model the water quality of the lake, or you can just use the normal interpolation methods to do the modeling. Thank you so much.
Thank you. Have I been given the opportunity to ask my question?
Please do.
Thank you, facilitators, and thank you everyone in attendance. I am Dennis Diofropio, a valuer and a graduate student at Gulu University. I wanted to get more clarification from Solomon, particularly about the different map projection system. Of late, it has come to the attention of a few experts in the GIS field that the map that we have been using, which has been developed using UTM, is not so accurate because it has, in a way, given us the perception that the size of Africa is almost equal to that of South America, which is not real. I just want you to shed more light on probably if there are some other shortfalls or shortcomings of the UTM system of projection. Thank you.
All right. Thank you, Danish. There are very many projection systems, coordinate systems. Now, all these systems, some of them have errors that I haven't talked about, of course, because of the content, the time. But just like you can see from this first diagram, that however much the Earth is a globe, and then you try to flatten it, you're going to always have errors. When you look at this map here, you see Africa, and then also you see the US. Now, when you just look at this map, you might think that the US is actually far much bigger than, where it's at the same size like Africa, which is not the case. Like Africa is far much bigger, but it's because of the projection that was used to come up with this projection. Now, this projection distorts the shape and makes actually these countries that are towards the pole to be their area to increase. Now, like this continent here, down here, you might actually think it's the largest continent, and just by looking at this projection system, which is not the case. So these projection systems, however much we use them, they have areas where they are best applied, and then in some areas actually they don't work. Now, each country may have their own projection system that they decide to use because it's the best for their country. So now that implies that if you're working in the USA, you can't use the coordinate system that we are using in Uganda, because it will have different errors. It will have maybe more errors than for us here. Now for us, we decided to use Act 1960 UTM 36 North. It's because it's what at least brings and minimizes the errors.
Yes, Chisa. As the timekeeper, we have 1 more minute to answer one question, and then we proceed to the next session. Thank you.
Yes, I think also we can follow up on email for the questions that are here. We're going to take records and then follow up the questions on email. Let me just invite the next facilitator to take us through. Let me stop sharing. Thank you, everyone.
Thank you, Kisa. Thank you, Kisa, and thank you, Jesse. Hi, everyone. Good evening. My name is Rohimana Chivuka. I'm going to be the facilitator for this next session. As I was introduced in the prior session, my session is going to be an overview of the GIS software that we are going to use. For that case, the QGIS. So I'm literally going to be giving a demonstration on what Kisa has been talking about. So we have an insightful something about QGIS, GIS in general, and QGIS in specific. So by now I'm assuming that we have downloaded our QGIS on our machines, as it was stated in the email sent before. Yeah. So I'm just going to start my QGIS right now. Yeah, if you're ready to follow with me, you can start by opening your GIS right now so that we can go through the session together. So you just need to come here to your Windows tool panel and then type in QGIS desktop. Yeah, it will come. Or if you have a short icon like me, I pin mine just in case I want to open it anytime. You could just pin it here on your toolbar and then just click on it and to open. So let's open our QGIS with me so we can follow through together. So QGIS is an open source software. By open source software, I mean it's free to get. You don't need a license for it. It's free in such a way that you can customize it for your own activities. For example, if you have a certain work that you want to do, a certain project that requires you to do certain processes, you could just make a code, a plugin of yourself like we are going to do, and use QGIS as a platform to run it. So that is what I mean by open source. Like anyone can use it, anyone can customize it for their own uses. It has a repository of so many tools that you can bring in and out. It's just it, it just allows you to customize any of your activities, any of your data analysis and visualization, data collections, and so on. So this on opening the QGIS, this is the interface that you're going to face. Yeah, this is how it looks like when you've downloaded it. Maybe the first time you've opened it, or maybe other times you've been using it. Always bring the screen. So I'm going to go through a couple of tools, processes, demonstrations that could give us an insight on how we use QGIS for data collection, data analysis, cleaning, which is very important, data visualizations, and so on. Well, like I said, this is the interface of your project, of your QGIS. You have this panel here. It will bring you the news. They can give you news, the current updates if available, current promotions going on in the QGIS. You can always find them here on login. Then here you have the project templates. You can create your new project here. For example, right now, we're just going to create a new project and then start working in it. So if you've opened up your QGIS, you could just double click here, and then they'll give you the whole pane for where your work will be. So this space here is where your data will be displayed as you put it into GIS. And then you have this bar here is the menu bar. The menu bar, it has like literally the menu. You have the menu having different components within it. You have here these small icons that you see here. They're called they're in what you call the selection toolbar. Yeah, here these ones are from a couple of toolbars that QGIS has maybe installed them for you. Yeah, because they're core tools that are launched within the QGIS, like very important tools that you could use every day. Like like the saving, the creation of layers, like I'm going to show you later. Yeah, and then we have here this other side, we have the layers panel. This one, it has your data, the data that you're going to put into the software that we're going to see. Here, when you put in data into your software, it will, the layer, the name, let me say the container of that data will be around here. And then we have this other side, the processing toolbar. This one you can turn it on and turn it off, just like any other toolbar that you're going to get from this other side. You can just turn it on and turn it off. So to create more space, you can just remove it for now. And then we have this other bar here. The one down is called the status bar. Yeah. So now the status bar has stuff like the coordinate. The coordinate is when I put my cursor here, the coordinate is the location of that area where the cursor is. So the coordinate, you can see it keeps on changing. So the coordinates of those areas keep on changing. Here you have the scale. The scale is the scale at which you're viewing your map, your data, the extent at which you're viewing your information. If it's okay, let me type in something here. So if you type in something here like let me say the world. Hold on, I think it's here. Okay, so if you type in here on coordinate, you type in the word world, it will bring you the whole global map. It brings you the whole global map. Now the scale is the extent at which you're viewing your data. Now you can see it's in millions. This is a very large scale. That means the information you're going to see is very little. You're only basically seeing the outlines of the continents. So if you want to see something specific in one of the countries in here, you may have to just zoom in. So as you can see, as I zoom in, the scale keeps on reducing. Yeah. So here you have the magnifier. You can choose to magnify your map.
Madam Rema. Excuse me.
Yes.
Please,
Yes.
I'm requesting that you show me how where you typed to put in the
world map.
The
Oh,
world.
okay. Okay,
Yeah.
you see this point where you have coordinate?
Yes, I'm seeing. I'm there.
Okay, so now you type in the coordinate space. You control all to select everything in there, then just
Mhm.
type in world, then enter.
Then it. Yes. Thank you so much.
Okay, so now you can see, you can as well go through your scale. Like when you zoom in, it reduces. When you zoom out, it increases. So this is the extent at which you're viewing your maps, which is very important. Like if you want just to generalize information, like for example, this one is general, it's just the world, the continent in the world. So we don't need to put the roads, you don't need to put the hospitals in each of the continents, because it's a wide scale. All that information will be more or less useless because the viewers will not be able to see it. So if you want to give a more detailed map, then you have to reduce your scale, or you could just zoom in and then see that your scale is reducing. So and then the other thing is what case I was talking about, the projection system. The projection system in GIS, any type of GIS, any platform for GIS, by saying any platform GIS is like, GIS is very wide. It's not only QGIS that can do analysis stuff. It's not only QGIS that can do visualization and stuff. There are so many other GIS platforms that we can use. Just the idea is the same. As long as you know how to do something, as long as you know the content in what you're going to do, it is all the same, more or less the same. So right here in the corner, you have what you call EPSG. Yeah. So like you can see, there's a pop-up right there in the corner. It's saying the current CRS is EPSG 4326. So that is the current projection system, the default that GIS has chosen, because it's a word projection. It's a worldwide projection. Yeah. So when you're starting your project in GIS, you should take note on which projection system you're going to use. So if you want to use the EPSG, you can just go ahead and use it. This is a world projection. But if you want to change it, or you have a specific projection that you want to use, you have maybe you're in Africa, you're in Europe, you're in Asia. The case has said there are different projections that fit those places perfectly. So that helps us to reduce errors and offsets in data. Yeah. So if you want to change this system, you just come and just click there on EPSG, just click it, and then you have this pop-up here, this window coming up. Now this window, it helps you change the coordinate system for you, for which you want your project to be worked in. Yeah, you have you specify the projection system, the area for which you want the projection for. Yeah, like Kisa said, in Uganda we use the UTM, the WGS UTM zone 36, because it best suits our area. So now here you have the filter. For the filter, you could just search. For example, here there's just too much that you can choose from. These are the different coordinate reference systems. They are different because each of them fits a particular area differently, perfectly for that area. It's created for that area. And by the way, even anyone can create a reference system for their area. You go through a lot of data collection, a lot of surveys, and you know, it's a lot of a project that you can create. For example, if I stay in Kampala and I want my project to perfectly fit the geography of Kampala, I could go ahead and do a specific project. By specific project, I mean a series of data collection, a series of surveying work on the ground, so that I can come up with a projection system that best fits Kampala. So right now, we can just search in here. To here in this panel, you have the coordinate system, the recently used projection system. So here, if you've been using several systems and you've saved them here, you don't need to come here and then search. You just come here and select. For example, if I want the word marketer and then I apply it, it will come. So like I said, it changes according to the area you want to fit. Like now you can see it has changed to that projection. This one could best fit maybe an area here or here, and maybe could, like you can see now, Africa looks more tinier than, more tiny than it was before in EPSG. Now this one is ESRI. It's another different coordinate system that best fits a certain place somewhere. So now if I want the one that best fits my country, I'll just come here and type in.
Yes, Remy.
Yes.
Yes, Remy.
Yes.
Please show us how you got that again. We need to see Bulungi.
Oh, okay. So you come here to where you got your pop-up, and then I recently changed my coordinate system to word marketer. I've ever used it somewhere. So if I want to do my project in that very system, I could just choose it here because I've recently used it. Or else you can just go through here and search. Yeah, and search. For example, let's say this one. It's just an example. So now you can see in the preview which area it best fits. Yeah, this one best fits this area. So if your work is in this area, then it's better use this area, because your work will be, the areas will be minimal when you use this projection system. So if, let me just type in WGS UTM zone. So yeah, so like Kisa said, in Uganda we use the WGS 84 UTM zone 36. Yeah, so you come here to WGS UTM zone and then start looking for the zone 36. Zone 36. Let me type 36. Okay, let me just go back. This one is 60. Let me look for 36. Zone 36. Oh, if anyone has gotten it, you could maybe tell us the number here that you use, that is showing on your screen, and maybe all of us can just search it here.
The number for WGS 84 stroke UTM zone 36 North is EPSD :32636 32636 636.
Okay. Nope.
You can just, Remy, you can just type in 32636. It will bring it.
32636.
32636.
Oh yeah. So that is a very easy way of searching for the coordinate system, because there are lots and lots of coordinate systems in there. So it's to your advantage that you have the number for that coordinate system. Well, if you don't have it, you can go through the hassle of searching for it. So when you click it, you can see the projection, the area for which it best suits. I can zoom in for us here, and then you can see. So this one best suits the areas in Uganda that are above the equator, right? Above the equator. So you can see it's from the equator to up. So this is 36 north. So if you're working below the equator, you choose the one of 36 south. Apply, then okay. So yeah, you can see even now other areas are totally distorted, but we have our area here in Uganda perfect. So maybe that can answer.
You have a hand. You have a hand.
Yes, please.
Yes, you have a hand. Isaac has a hand. Isaac, please come.
Hello, this is Isaac. Thank you, Rehema, for the presentation, but I need clarification on still the coordinate system. I've been using GIS and AutoCAD. Sorry, it's not part of the module. But for Uganda, I've been using ARC 1960 for a while. I don't know why you're seconding WGS, the UTM bit of it, but I still think ARC 1960 covers Uganda better. I can still share its EPGS number and you try it and see the area it covers.
Well, thank you, Isaac, for that concern. But
yes,
yes, Kisa, please.
Yes, thank you for that. Yeah, I think in Uganda we have two coordinate systems that we use, WGS 84 and then ARC 1960. There are reasons, of course, behind. So whether you're using ARC 1960 or you're using WGS 84, you need to know exactly, depending on the project that you're working on. Some of the projects, they might specify to you to use a different coordinate system. So you will have to adhere to the project requirements, and then you work with WGS 84 if they want WGS 84. If they want ARC 1960, you also work with ARC 1960. As you well know, ARC 1960 also has issues, which of course it's a different case. So just depending on the project requirements, you can actually use any kind of coordinate system. So for Uganda, basically we use WGS 84 UTM Zone 30 North, or you can use ARC 1960. Now the variation is the datums. You can use the ARC 1960 datum or the WGS 80 datum. So the ARC 1960 datum, if you know the history of how it was established, the traditional methods, how it was established by surveying from South Africa up to Uganda. And then also WGS 84 is the more recent, because it's established by GPS and satellite GPS satellite positioning, yes, to obtain that datum. So basically you have any, depending on the project requirements, then you'll have to choose any. So I think it's okay either that you prefer to use. So me basically I can use any, especially now for demonstrations. Now for now, Rehema is using WGS 84, which I think is okay. But if you still want to use ARC 1960 UTM 36 North, it's also, I think, absolutely fine.
Okay, thank you, Kisa, for that insight. Yeah, but I understand very many land surveyors use ARC because it's the traditional that we've been using. But as Kisa said, there have been modifications in the datums, and then here we are using WGS 84. Okay, so but thank you, Isaac, for that. I'm sure very many of us have been wondering what it is, and yeah. Okay, so that being said, that is that. So moving on, we have a very important step in any computer, software, is saving your work, because if anything happened, you would better use your work and you would have wasted your time. So saving in QGIS is not very different from any other software like Excel and Word. You just need to save. You come to project, or project and then save as. Yeah, there are also shortcuts here that you can use in case you don't want to navigate through the whole screen with the mouse and stuff. You could just use your keyboard, Ctrl+Shift+S, and then you save your work. So just go to any location on your computer and then save your work. I'll save this my demo. and then I can save. So you rest assured that the next time you want to open this project, you don't need to first open the GIS and then log in your work or what. You can just come here and double click on your project and then to open in the QGIS. So like you can see, it's now saved. So every work that you do and save, it will be saved in your demo GIS project. Or on the second, otherwise, optimally, you can use open from recent. You can see all your recent projects that you've been working on right here. If you have a couple of projects you've been working on, you can go and select each of them. Okay, so moving on from this bar, we have this one, the layers bar, the layers tool panel. So the layers, like I said, it has the layers. These ones are called layers. Yeah. A layer can take on different formats. It can be a vector layer or a raster layer, just like Kisa said. It's the two types of data that we have. So if you create a layer, it's either vector layer or raster layer. And when you import your data, putting it in your software, it will come and appear here. So anytime you want to view a layer here, okay, right here I turned on to world maps, but let me remove this one. So to remove this one, I can just right click on it and say remove the layer. So I can have one of them, just this one. So you can put in as many layers as you want, as many layers as your data forms, as many layers as you created during your data collection, and as many layers as you want your analysis to take. So it does not limit you from how many layers you have. It's just the organization that could put you off, which is a very important step in QGIS. So to turn on and turn off your layers, you just come here, turn on, turn off, turn on, turn off, turn on, turn off. So we are going to see more how you can toggle these layers when you put more layers in our next demonstrations. Now here we have the tools that I talked about. These are the core tools that come with GIS, QGIS. Core tools, I mean those ones that you may not do without. Yeah, like saving your work, zooming, panning, all this. You can just go through all of them. They are limitless. Like for example, here you have the attribute table. The attribute table is a table, is like an Excel that has all the information about your data. For example, if you have a point, and then that point is a location for maybe Mulago Hospital, and maybe added to Mulago Hospital, they have the number of beds, number of patients, all those. You can view them you can view data about your layers right here on the attribute table. So these tools are limitless. You can add as many tools as you want. You can right click here and then add as many toolbars as you want. Like here, you have as many toolbars as you want, and then you have as many panels as you want. So for example, let me choose the browser panel. I want to choose the browser panel, and then it will come right here. So now the browser panel, I'm sure some of you have it right now because you just open your PC. Your QGIS, I removed mine to create more space, but the browser panel directs you to like browse, to browse data into your GIS. Like you can browse from your computer, you can browse from a website, you can browse from anywhere, all these, yeah. So even here you have data that is embedded in these. GIS does not start with you going to the field. Yeah, it can start with you by just opening your PC and start creating the data right here, because you can have the data right here. without you going to field. Like now that we have curfew times and stuff like that, and you want to do something for your village, you know exactly where your village, your health centers are, your water points are, your schools. You just come here and create them. So now that takes us to creating. How do you create the data? So let me first go through these menu tool bars, and then we can see how to create our data. So like I showed you this one. It can create a new project. You can create a project from a template. Like for example, you have an organization that has a template. That has template. A template is a pre-organized project. Yeah, it's something maybe you've been doing over and over again, and you don't have to redo it every time. So you can, all these, you can just go through them. You can, for example, when you're going to produce your map, to print out the map, you can go here to the layout manager and then organize your work into a more presentable form, which we shall look at, I think, on day 2 tomorrow. Then you have your edit. Your edit is not active right now because you don't have a layer that is editable. Editable means you can change the data within it. Yeah. For example, if I have the word map here, it's not editable. I cannot edit this map, but we shall see about it. So you have the view, all these tools, like I said, there are limitless tools in here. You have some of these menu toolbars, menu boxes. You don't have them because I added them myself from the previous works. Maybe I might have done, but you can create them. You just have to come to plugins. Now, plugins is a tool that helps us to install more tools into GIS, QGIS. That is why I told you that QGIS is an open source that anyone can add in a tool. Anyone can disable a tool if they want to use it on their laptop. So if I want to install a tool that will help me do some activity or will help me do some analysis, I can just come here to install it. So I want us to try to install a plugin so we know, because it is going to be an often activity for you when you're doing GIS, because it's not like everything you're going to do in GIS is embedded here. No, you could keep on installing as many plugins as you want, as many tools as you want. So you come here to manage and install plugins. I hope you're together. Manage and install plugins. So here you have plugins. All the available plugins are 725. So you can see how much this software is huge. It's 725 plugins that you can install into your GIS. And each of them does something very interesting that you never know. I'm saying GIS is not learned in a day. So you keep learning every day and every day. Now the point is you keep learning GIS every day. And practice, the more you practice is the better you become. Yeah, the better analyst you become. So here you have all the 725 tool plugins.
Excuse me, Madam Rema.
Yes.
Sorry to disturb you, but I just have a small issue here on my computer.
Mm.
The QGIS I'm using 3.18.
Okay.
But then when I tap on what you're tapping there, I'm seeing you have plugins, all you have 725. Me, they are showing me I only have 7. Is there a way I can modify it? Or?
Yeah, that is a common. It's a common. I don't know if it's an error or something, but sometimes it may not all come here. So you may have to restart your QGIS and try again.
Or maybe it's off internet.
Hello.
Yes.
Yes. Yes, sir.
I can help.
Yes.
I'm also using 3.18. But for the 7, they are for installed plugins. The ones that are not installed, they are 720. So all of them, I think they contribute to the 728.
Okay.
Oh yeah, you go here to the all the plugins. Some of you may have here installed. installed a few because I've also installed a few. But yeah, on all the plugins,
I've gone to all, but I'm still seeing 7.
Okay.
Remy.
Yes.
Remy. Maybe they also need to know that they should be connected to the internet. Some of them are defaults, and then others come when you are connected to what? To the internet.
Oh.
Yeah. Thank you.
Okay.
So,
Okay.
so
Thank
you
you
can
so much.
connect to the internet and try again, or you
Yes,
can do
madam.
the otherwise.
You can continue. You shall what? Try to catch up.
Okay. So then here you have the installed plugins. These are the number of plugins that I've installed so far in my QGIS. Those ones that are not installed, they're all here. You can just search and install. Then also you can install from a zip file. A zip file is, for example, when you've gone to a browser somewhere, maybe Google Chrome, and then you've searched for a plugin, downloaded it on your PC, so you can come here and install it in QGIS from the zip file, because they're always in zip files. So you can come here. Are you guys hearing me? Can you guys hear me? Guys, I'm so sorry about that. My internet skipped a bit. So let me share again. You can see my screen again.
Yes, Remy, you can continue. We can see your screen now.
Okay.
Yeah.
Okay, just a minute. Zoom. Okay, so just say I would like to share my screen. Could you make me the host? Okay, thank you. Okay, so like I was saying, I really don't remember what I was saying earlier, but okay, so what I was saying is that the plugins, you can install as many as you want. So we're going to try installing one. Also, the settings of the plugin, you can check for updates on start. Like QGIS can keep keep you posted on the updates on any plugin that you have installed. You can show experimental plugins. Experimental plugins are those ones that are like the word said, experimental. People are just still trying them on. People are still trying them on. So but you can still use them because they work. They can perform what you want. And also those that are depreciated, like maybe have been upgraded or changed, and maybe some tools are depreciated. So now when you want to install a plugin, you just come here and search. Yeah, and search one. So I want us to install a plugin called ORS tools, because we shall need to use it later on in our other sessions. So you could search ORS tools, and then it will come here. So you have if it's not installed, then you need to tick it so that you can install it. Yeah. So if it's not installed, you tick it and then say install. Rather, because mine is being reinstalled because I might have installed it earlier, but you have install here, so you say install the plugin. It may take like a few seconds to install. So after you've installed the plugin, then you can close. Yeah. Let me try to install another plugin with you guys. So let me see a plugin here. Okay, any. So let me choose the DSG tools. You say install the plugin. It will take a few minutes to install. You have to be connected to the internet because you're downloading it from a server somewhere. So as you install your plugin, they also show you what the plugin does here. Yeah, they have a description for you on what the plugin, what you expect a plugin to do, what it may not do for you. Yeah. So the overview of the plugin that you've installed, they're all right here. You can read through. Just a minute. I overstressed my GIS. Do we have any questions as per now? Okay, so like I said, you have your instructions here, what the tool does, what it is called, what it was aimed for, and blah 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 blah. So all you need to use the tool is there. You can always go to the help button and search about it, and then they'll tell you it's installed successfully. So if you want to see your plugin, it will either bring its own toolbar here, yeah, or you can just go here to plugins and maybe look for it, or it will create its own menu bar here. Yeah. So either way, you'll have to see where your plugin has gone and what it does. So as I said, each plugin has lots and lots of things that it can do. So now this one, it configures about what, manage databases from server. I think this one is some sort of Python code that you use to do some stuff. I also don't know what it does, but yeah, if I needed something that is related to that, then I can do it. So this browser, like I said, you can browse data from anywhere. There's also preset data here. There's OpenStreetMap, there's Google Satellite. You can choose any. So I'll maybe choose OpenStreetMap. To put it here, you can just drag. You can just drag and put it in your panel, and then it will come here. The OpenStreetMap. The OpenStreetMap is like a base map. Yeah. So you can just zoom in, say to Uganda. Yeah, just like that. So now this takes me to how to create data in GIS, how to import data and how to create data in GIS. Yeah. So like you've seen these, you can have a satellite image, you can have the satellite image is usually that raster, like an imagery. Then OpenStreetMap is this. It's mainly vector data. So let me try to put the Google satellite. So yeah, this is that. So let me turn off this and see if I can zoom in. So like Kisa elaborated for us, it's raster data, like images, like basically images. So now, like I said, if you stay in maybe Chira and you know where health centers are, you know where schools are, you know where, and you need those points for maybe a given analysis somewhere, you can just come to your laptop and start creating the data for yourself. Yeah. So let me say we want to collect points along a road. Yeah. You want to use them for something, like you need points along the road. How do you create points along the road without going to the field, without going to into the streets with your phone or something like that? So what you do is you come here and create a layer that is going to contain your points. Yeah, you create a layer which is going to be a vector layer containing the points of interest that you want. So how do you do that? There is a tool here called data source manager toolbar. Yeah, I don't know if you guys have it, but if you don't have it, right click anywhere in space and look for it. Where is it? Toolbars, data source manager toolbar, and then check it, and then you will be able to see it. So if you want to create a layer, you could come here to to layer, create a layer. Yeah, so you can create any type of layer, a geo package layer, a shapefile layer. These are data formats that you keep your data in. Their formats, you could have a geo package, a shapefile, a GeoJSON. All these ones is a format for which your data is. So you choose a format for the data depending on how, because they also have different sizes. Depending on, maybe after this you're going to take it to some other software somewhere, so that software may be able to read the data that you've collected from GIS. Yeah, so any layer that you create, you have to have maybe a background on what format that you want it to have. For example, this GIS can read as many formats as they can read CSV from the Excel sheets. It can read special shape files that are created in GIS. Maybe you could have used another software somewhere, like maybe Google Earth, and you saved it as maybe KML. You save it, you can bring it in here. So if you're going to export your data somewhere and you're going to put it elsewhere, it's important to know the package, the format you're going to export your data. Just like in the any other movies and what you have, I don't know, MKV, stuff like that. So creating a new layer, I'll just create a new shapefile layer, because usually we use shapefiles in GIS. So here you name it the layer that you want to create, say points along road points along road A. Points along road A, and then the geometry type. The geometry type is which type of layer is it going to be? Is it going to be a point layer? Is it a multi-point? These ones are more or less the same. They have their differences, which you can't see now. But then, if you want just point data, you can use point. If you want line data like roads, rivers, anything like line, you use line. And the polygon is maybe building, river, a lake, demarcation somewhere, a reserve, or what, anything. So this one is going to be a point data. It's going to be a point geometry point. And then here, if you want to have attributes connected to it, for example, it's going to be point A. It's going to be, maybe you're also collecting the height of that point. Let me not use the height. Maybe you're going to say opposite Kakande's church, opposite this church, your description for your point. So you add here, you add it here. So you come here to the name of the field, say
Yes, Remy.
yes.
Some people are saying that you are too fast, and then I don't know, maybe you can try to reduce the speed as yeah.
Oh, okay. Sorry about that.
Thank you.
It's just too much information and time is limited. Okay,
Yeah,
but
you can cover a limited information, and then the other one we shall cover later. Don't worry.
okay, so I'm going to
Or
start.
maybe, yes, or maybe you can ask the participants if they agree, you can extend by a few minutes after 5. If they don't agree, we can stop at 5. Eh?
Okay.
Yeah.
So I have 6 minutes, and let me see how we can do this in 6 minutes. Get the best out of 6 minutes. Actually 5 now. Okay. So like I said, to create a layer, you come here to this toolbar, layer, then create a layer. So you can create any of these layers. A shapefile, a virtual layer is not advisable to use if you want to keep your data for data use, because a virtual layer, it only contains your data virtually. It does not hold the data itself, like save the data in a particular location. It only helps you in that very time, that project. That's why it's called a virtual layer. So I'll create a shapefile. So now a shapefile, I will name it, the name, what the name that is going to appear here is what you put here. How you want the name to appear here. Usually I would prefer it's descriptive of that actual thing. So this one is going to be points along road A. If you have your roads named A, B, C, and D, yeah, then the geometry type is going to be the type of data that is going to be. This one is going to be a point data. If you want to draw the whole road, then use the line, because you're going to draw a line. If you want to use a polygon, say you're going to digitize a building, then use polygon, because it's going to be an enclosed line. So I'll choose point. Now this one, the new field, it's optional to leave it. Yeah, but if you have different information that you want to put on that point, then it is advisable you add add other fields as you're creating your layer. So now I want my points to have the name of the point. And then I also want it to have a description on the location on top of the geographic, on top of the coordinate information. I want it to have a more local way of describing. Yeah, so I'm going to add here a name. So I'll say this is going to be the name of that point. It's going to be a text. So if you want to name, maybe give it a number, you say number. If you had, maybe it's another kind of information that you want to put numbers, you can use decimal. Or if you want to say the date for which you collected this point, then you can describe the type to be date. So you cannot enter anything else. If it's text, you can only type the letters. If it's a whole number, you only type whole numbers. If it's a decimal, you can use the point, blah, blah, blah. If it's a date, you can't enter anything in this field that is not date related. Okay, so this one, I want it to be a text. So I'll name, maybe this is, maybe Kamwesi, this is maybe Watseka, something like that. So I add to the list. So now it will come that I'm going to have the ID of the point. I'm going to have the name of the point, and maybe the description of that point. The description. Description. Looks like the numbers can be limited here, but yeah, you can use that describe. So it's going to be then, okay, it can also be a text, so I add to field. So then I'll say, when you've finish to put all those things that you want, then you can say okay, and then you have it here, points along line. So this thing is empty. Yeah, like you right click and see the information you need, the attribute table. So you can see it's empty. You don't have any data you need. So I want to create my points along this line. Yeah. So to edit this layer, I don't know if you can see this pencil right here. You have this one, the pencil. It's in a barcode digitizing toolbar. If you don't have that toolbar on your screen, then right click anywhere on your space here, and then look for that toolbar. It's called digitizing toolbar, and then check it, and then you'll be able to see it. So now if you see this point here, it says toggle editing. That means enable editing. Yeah. So select the layer for which you want to edit, then say enable editing. So now this one will allow me to create points. Yeah. So now when you enable editing, you look for this tool right next to it. It says add point feature. That means it allows you to start editing on the map. Yeah. So I'll click on it and say this is, and then click where I want my point to be. And then this thing will, this pop-up will come. Let me expand it a little bit. So all the attributes that you added to it will come along it. So it helps you to add your data, your attributes along as you're collecting your data. Yeah. So the ID is a unique identifier. This one is going to be 0.1, it should be 0.1. A unique identifier is what identifies it the best. If I want to query something and I say number 1, it will only bring me that point. That is the ID, the unique identifier. Then the name could be maybe Wachiseka. Describe maybe say milk products. Milk products. Milk products sold. And then I will say, okay. So I don't know if you see my point, but it's there. It's there. So I can go along and create more points. This is number 2, the description and the name, and then the description. Okay. And then number 3, point, name, description. Okay. So now you can see my points are created there. You can also collect your points at a given interval, at a given length or width, or that you want to create your points to be. Yeah. Okay, so that is for the point. Let's try creating the line. Or okay, the line. Let's start creating line. So after editing that, you come here to save. You save your edits into that layer, and then you stop editing. Yeah. So now if you try to open your attribute table here, you'll see that 0.1 is called this, and this is the description. 0.2 is this, and this is the description, like that. You can do this. There's so much tools here in the attribute table that you can also use to manipulate your information. So I was thinking that maybe we could create the lines and maybe polygons as practice on our own. I don't know if that would be something that you could use and see how you can deal with the points and lines. I think it's good to explore.
Yes, Remy.
Yes.
What I am thinking, our participants can go back and explore how to make a point, a line, and a polygon, but rather show us one more thing, how to import vector and raster, and then we can answer the questions, and then we call it a day.
Okay, so thank you, Jesse, for reminding me. Like I said, you could have your data somewhere on your PC, or you can create your data right on your PC. So if you have your data maybe somewhere on your PC, how do you import it in here? There are several ways in which you can import the data here. Yeah, I'll go through them from the longest to the shortest. So the first way is to come here to layers here, right here. And then you say, just like you can create a layer, you can add a layer. Yeah. So, and also there are different data types that are added here. You can see all these. So if it's a vector layer, you come here to vector layer, you click, and then it will bring this this pop-up window. So this one asks you to browse where your data was saved, say on your computer. I trust that data was sent to us, sample data was sent to us for day one that you could use. I hope you downloaded it. You could use, maybe you saved it on your PC. You could browse it. You could browse to where you kept it. Yeah. So if it's on the desktop, you go to desktop, and then you have your data. So if it's point data, if it's point data, well, these are the data formats that I was talking about. Now, a shapefile, when you create a shapefile, it comes with other different extensions with it when you export it. But most importantly, what you want is the one with shapefile, the SHP. The SHP is the one we import. Yeah. So when you choose the SHP, you say open because it stands for shapefile. And then you say add. When you add, it will come here. So to view your data, because it may not be in this location that you were in, so to view your data, you come here and right click on the data, then you say zoom to layer. So you can see your points there. Yeah. Make sure you save your work because the time you close your GIS, you will not find these layers again. So the same thing for that is for vector layer. So for raster layer, it's still the same thing. You come here to layer, add layer, then say add raster layer. Raster layer, like anything raster. So you can browse that day one data had this Facebook AI population data. Population data is it was saved as a TIFF. A TIFF is an image, just like in your phones, like JPEG, blah blah blah. They're all TIFF formats. They're all raster formats. So you if you try to actually, let me try this. If you say I'm importing a vector layer, I'm importing a vector layer, and then you choose a raster layer, it will not import. Let me try this and you see. You say add. So you see they'll bring you an error that it's a TIFF, so it's not a valid geometry. It's not a valid data type that you've chosen. So I'll choose the raster. Raster. Open, add it, and then you can close. So you may not be able to see, but you can see this is the raster layer that we're talking about. The pixels, they look like this. Yeah, for this type of data, specifically this one. Another one could be an image or what, but that is how you can import that. Alternatively, one of the fastest ways is to just drag and drop. So let me first remove these layers and then we see. Let me remove this one and this one, right click and then say remove layers. Alternatively, you can just come here to your browser and then search on where you have your data. If it's in the C drive or the D drive, you search and then double click on it. Let me show us. Double click on it. Say buildings, and then have the building shape. Double click on it. It will come here, or you can just drag and drop it here. Yeah. Okay. So let me show us the fastest way of importing the data is to just drag and drop. Just open your file explorer. Come to desktop where my data is. I have my folder called day3 data, and then I want to import the highways, the Zombo highways. So I'll drag and drop it here. So to see the highways, you can see they've already come. So that's the fastest way to import your data like that. If you want the buildings, the boundaries, I could just let me import the villages, drag and drop like that. Okay, I know we are already 9 minutes past, so I could take 1 to 2 questions and maybe we can close this.
Yes, Juko, you can ask your question.
My question, the problem I had is I couldn't see the Google satellite, that raster, the raster layer.
Oh, okay. Well, if you don't have it, it's maybe because you don't have a certain plugin installed. This one, you have HCM GIS. It has different that base layers that you can have. You can have a base map of any of these. So if you want this one, you go back to plugins, manage and install plugins, then type in HCM GIS. You can try that out. You have very many base layers that you may want to have.
Okay.
You can also download any of these. This one has as many base layers as you want. You can keep shifting from one to another.
All right, that's fine. Thank you.
Mm.
David Kakoza, you can unmute.
Yes, thank you very much for the presentation. It's quite wonderful. Well, mine is with the attribute table. Can I add fields? For example, I've realized I left a field. I need to know how to add a field, for example.
Okay, for the attribute table, there are also a number of tools in there, but because before you edit it, you need to make sure it's editable. You also take that pencil so you can activate most of these tools. So if you want to add a field, you can come here. There is a tool there, new field. So when you click on that, it will bring you to name your field. So it is going to be this. And then you can put a comment if you want, and then is it going to be a string, a whole number, and then the length, if the length is going to be long, you can as well increase, and you say okay with that. Then after you can come here to open field calculator, so you can add attributes you want. Or if you don't want, if it's a computation, like you want to compute something in that, say maybe area of a given polygon somewhere, these polygons, yeah, you can do that. Or you can just type in. You can just type in. It's going to be a number. So I was typing letters. That's why it wasn't typing. So it's going to be a number. That then after you can save, and then stop editing.
Remy, lastly, we can take Isaac and then we can call it a day.
Okay.
Isaac.
Yeah, thank you, Remy, for this wonderful presentation. My question, if some data using some other system and I still have another data set that's, let's say, faster, and it was also fit into my project CR. Thank you.
Oh, I didn't get it well.
Isaac, please come again. Yes, Isaac, we did not get your question, please.
Isaac, your internet was breaking. Could you please read
Isaac is off. Remy, I think we are good to go.
Okay.
Yeah. Otherwise, you can give your concluding remarks and then you can conclude the session. Yeah, thank you.
Okay. Thank you guys for coming in. It's been a pleasure. Really, the numbers have been high, which is we are so grateful. Like we could send our information to as many people as we can. And thank you for honoring our invite to come and attend our sessions. As we go on, we are going to be interacting more and more. You can always send your questions through the WhatsApp group, and maybe comments. We can or an email. We could always get back to you guys.
Chisa also has something to say. Yes, Chisa.
Okay. Thank you everyone for showing up for the training. Just I wanted to say that the questions, all those ones that haven't been answered, they will be answered and sent via email. I think everyone will be copied in, and then with the answers to the questions that we are not able to answer. Thank you once again, and have a nice evening.
Thank you guys. See you tomorrow, same time. Have a good day.